Hi there, my name is Sam Heglin, and I will be doing my video project on the fossilization process and radiometric dating. Alright, so the fossilization process, it all begins when a form of life or an animal dies, and it has to be quickly buried in sediment. Um, it has to usually be around mud or water, because if it isn't and they end up staying on the surface of, of the earth, a bunch of scavenger animals or predatory animals might get to the carcass, or um, the exposure of sun and other elements will quickly decay the body. So it is important for an animal, in order to become a fossil, for it to be quickly buried. So over time, sediment compiles on the top of the bone, and then it compiles the bone into sort of a rock. During this time of the composite uh, material being compiled on top, minerals seep down into the buried bone, which strengthens the fossil into becoming a rock, and this is called permineralization. I have trouble pronouncing that, but that's what it's called. So scientists and archaeologists actually go and look for sedimentary rock, because that's where you are most likely to find fossils, just because they're usually surrounded, or um, sedimentary rocks usually at like the bottom of old riverbeds and stuff like that, and that's where a lot of these dead animals and fossils would be found, because if an animal died and sank to the bottom of a river, um, the scavenger animals and stuff like that couldn't get to it. So, the radiometric dating system, um, it is used to estimate the ages of rock based off of the radioactive elements in it. So, this is a process where you use the half-life of what is known as an isotope, or part of the parent atom, um, and you measure it by the amount of isotopes that is still left within that atom. So for an example that I have here, it was if you measured a rock containing carbon-14, if only half the isotopes were left in it, there would roughly be about 5,730 years, um, or that's how old it would actually be. So as you can see in the picture, um, in this slide, you can see that at the beginning of its age, or like the creation or time of death, it'll have the maximum amount of isotopes that it has, and then going down the chain, or over the years, it slowly loses its isotopes, and that's what scientists use to date the rock. So there's even though radiometric dating is pretty excellent when dating rocks, there also are some flaws to it. So when dating items that are very old, we have to assume. So what I mean by that is that since you don't know that the isotopes are decaying at a constant rate, you can only assume that they are. Also, you don't know the conditions of the rock that you're dating, or what it went through over an extended period of time. So conditions might have changed for the rock, um, causing it to decay faster, or to decay slower. So an example of this flaw would be why scientists estimate that the Earth is between 4.55 and 4.6 billion years old. They leave a 50 million year time gap, because at, scientists can't um, they can't examine, or they couldn't examine the current existence, um, or the past uh, environment in which the Earth was created, and also how fast or slow the isotopes decayed throughout the Earth's crust and such like that. So that's why they gave that 50 year or 50 million year um, time estimate, or time gap. So yeah, I hope you enjoyed my little presentation on radiometric dating and the fossilization process, and I hope you learned something. Thank you.